My name is Putri and my group mate is Muhammad AMIRUL, Muhammad IKHMAL, Muhammad AZRIE and NURFARISSA. So I will explain about meeting fulfillment and online discussion. Firstly, we on the 3rd March 2020, we review of agenda minute 9:30 AM. We discuss about group organization chart and finalize it. Overview regarding to the project instruction given. Discuss roughly on finding structure analysis drawing for the BIM design. And we closing remark with member are being assigned to make some research and finding more drawing that's suitable to be discussed and decide on the next meeting. Next, we review agenda for 13 April. On 11 AM, we discuss about progress and decide to finalize our project by choosing the right drawing and decide to redesign it. On 11:30 AM, we distribute tasks in report for project among team. For calculation part, continuous beam for Farissa, simply supported beam AZRIE, one-way slab IKHMAL, two-way slab RASYID and me for moment distribution. Next, on 1st June, we review agenda on 8:30 PM to update on project progress of every member, parts in report writing, and review of minute 9 PM. Member are required to finish their part a week before submission date. And last meeting on 35 June 2020 on 9 PM, secretary sent a report which is AZRIE compilation in WhatsApp group for everyone to check if there is any mistake or information need to be correct. And lastly, we review all of the report by group member, and member who are appointed to do slide and video present are remind to do their part and submit on the submission date stated from lecturer. That's all. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is NURFARISSA binti MOHAMED NAZIM with matric number AN 180133, and I'm going to talk about the task distribution among my group members. Okay, for the first group member is Muhammad IKHMAL bin JAMALI, 21 years old, and he is the group leader of our group, and he proposed the drawing details on method and task. He also prepared for video presentation. He lead the meeting session and observed work progress, and lastly, he committed to the video presentation. For the second member of my group is Muhammad AMIRUL Rashid bin Muhammad SAIP, 24 years old, and he is the assistant group leader, where he prepared for conclusion of the report and create a meeting room in WhatsApp and Google Classroom, and he also committed to video presentation. For the third member of the group is Muhammad AZRIE bin AMRAM, 21 years old, where he is the secretary of the group, and he prepared for the table of content for the report, overview the final report, and committed to the video presentation. For the fourth member of the group is PUTRI SYAHIRAH binti IDRIS, 21 years old, and she is an active group member where she solved the problem, and also she prepared for appendix and references of the report, focus on analysis calculation of the design, and prepare minute meeting, and also committed to the video presentation. And lastly, the fifth member of the group is myself, NURFARISSA binti Muhammad Nazim, 21 years old, and I am also an active group member, and I'm a researcher, and I do prepare for the introduction of the report and find the related article, and also prepare the group profile and committed to the video presentation.
This topic is about the actual design process, start from obtaining architect drawing until producing structure drawing. Architect drawing. The architect create the drawing based on what client want. And basically, architect have a portfolio of past project to review and possible example of their process. The architect evaluate the program, schedule, and budget from the first stage of the architectural design process and prepare the rough sketch of the building schematics to review with the client. Structural drawing. Structural engineer need to design structure based on architecture plan. The engineer involved translating the schematic that they are suitable for construction and permit submittal. And this is plan view drawing from Ame Architect, which is one-story bungalow at Taman Bukit Lela, Mukim Setapak Gombak, Selangor. The good structural design must be include first, reliable structure system or safety. Second, utility. Next, economy. Fourth, aesthetic. Next, constructability. And lastly, durability. Stakeholder involved in the design stage. There are normally 4 different steps within the design stage, and they include programming and feasibility, schematic design, design development, and contract document. Stakeholder involved in the design stage is architect, structural engineer, service engineer, for example like M&E engineer. Lastly, specialist designer.
Calculation for simple supported beam. First is the specification. The effective span we have is 4.05 meter. Characteristic action, permanent action GK is 15 kN per meter. Variable action QK 10 kN per meter. This is all we refer from the EN 1991 11 section 6. And the design life is 50 years. Fire resistance is R60. Exposure classes is XC1. We refer from the Eurocode book. And the material. Characteristic strength of concrete FCK, we have 25 millimeter square. Characteristic strength of steel, 500 Newton millimeter square. Characteristic strength of link, 500 Newton millimeter square. And unit weight of reinforced concrete is 25 kilonewton millimeter square. Then we assume phi bar 1 25 mm, phi bar 2 10 mm, and phi length 8 mm. Next is the size. Overall depth from the length we divide it by 13, which is 4050 divided by 13, we have 312. Then the width we will, from the range of 0.3 and 0.6, we will times with h, and we get the width is 156. Then use B and h is 150 times 300. The max beaming for fire resistance based on this design is 100. Next is the durability, fire and bond requirement. Main concrete cover regard to bond cement 20 mm. Minimum concrete cover regard to durability 15 mm. We refer from the Eurocode book. Main required exit distance for R60 resistant ASD. And the formula used is ASD equal to A plus 10. So the A is 35 based on the Eurocode book. 35 plus 10 is 45. And the main concrete cover regard to fire, using this formula we will get 24.5 mm. Allowance and design for deviation 10 mm. Refer from the Eurocode book. And next is the nominal cover. use this formula and we will have 34.5. Then the C norm we will take 35 millimeter. Loading and analysis. Beam self-weight, we will have 1.125 kilonewton per meter. Next is the permanent load. GK is 15 kilonewton per meter. Characteristic permanent action GK. First with the beam self-weight 16.125 kilonewton per meter. Characteristic variable action QK 10 kilonewton per meter. Next is the designation WD. Using this formula we will get 36.77 kilonewton per meter. This is the shear force and bending moment. The shear force we will get 74.46 using those formula. Bending moment we will get 75.40. Next is the main reinforcement effective depth. We will get 232, 55.5. Design bending moment 75.40. Finding the K we will get 0.374 using those formula. Radius revolution 0%, revolution ratio D equal to 1. We will find K bar. We will get 0.167. K is more than K bar. Then using the compression reinforcement required Z equal to 0.82D, we got 190.24. The X we will get the value of 0.53, which is more than 0.38. The compression steel will have yield FST equal to next is the area of compression steel. Using this formula we will get 722. Then the area of tension steel 1129 millimeters. And we will use 6H12 and 3H20 as our bar, which we refer from the Eurocode book. Then the mean and max reinforcement area we will get 0.0013 BD. Using this formula we will get 45.24 millimeter square. The AS max using this formula we will get 1800 millimeter square. Next the shear reinforcement design shear force we will get 74.46. Then using those formula we find the VRD max. After we find it we will use angle is less than 22. Use this formula and we get 15.94, which is 22. Then we will use it as our feet, as our degree. Chord is 2.5 value. Then we find the shear length 0.239, trailing H6 ASW 28.3. Find the spacing using the formula we will get 86 mm. The maximum spacing 174. Next we use H6 equals 85. The minimum length we will get 0.12 following this formula. Next we try the length H6 ASW equals to 28.3. The spacing we will get 235.80, which is more than 0.75D. Next we use H6 125. Find the shear resistance of minimum length for 51.1. Is the link arrangement. Additional longitudinal reinforcement we will get 396 kilonewton. Next we will find the AS. AS we will get 230. Next is the deflection. Center require tension reinforcement. We use this formula and we will get 0.032. Reinforced reinforcement ratio 0.005. Center required compression reinforcement 0.021. Factor for structural system is 1. P is more than P naught. So we will use equation 2. Equation 2, after using equation 2 we will get 20.77. The modification for span greater than 7 meter, we will 7 is divided by our overall length and we get 1.75. Modification factor for state area provided as proof divided by as request, we will get 0.835, which is more less than 1.5. Therefore, the allowable span effective depth ratio is for 0.35. Then we calculate the ID actual. We got 70.46, which is less than the ID allowable, which is okay. Lastly is the cracking. Limited cracking width is 0.3, referring to the Eurocode book. The shear stress we will get 222 Newton per millimeter square. The max allowable bare spacing is 150 millimeter. The bar spacing as we will got 17.5, which is less than 150 millimeter, which is okay.
Hello everyone, my name is Mohammed IKHMAL. So my part I will tell or I will present for the calculation and detail for one-way slab. Alright, for this one-way slab I have 5 main points that I would like to present. The first one is slab thickness. The second one is durability, fire and bond requirement. The next one is loading and analysis. For the third one, main reinforcement, and the last one is shear, deflection and cracking. So let me present for the first main point, which is in our project we decide to choose our design for one-way slab at the laundry and toilet. So for long span or LY, we use 8.1 meter. For the short span, 2.4 meter. To make sure the slab is one-way slab, we divide Ly over Lx equal to 3.38, means that is greater than 2. So for the characteristic action, as usual we use 1.35 GK plus 1.5 QK. For the permanent one, which is GK, we use 1.0 kilonewton per meter square, excluding the self-weight. For the variable one, GK, we use 3.0 kilonewton per meter square. So we designed this building. Design life is around 50 years. We refer to table 2.1 in 1990. For fire resistant, we use R60. For exposure classes, XC1. We focus to material. Characteristic strength of concrete is 25 Newton per millimeter square. For the characteristic strength of steel, FYK, is 500 Newton per millimeter square, and the unit weight of reinforcement concrete is 25 kilonewton meter cube. So we assume the diameter of bar is 8 millimeter. We go through to the slab thickness. For the minimum thickness for fire resistant is 80 mm, that we refer to table 5.8 EN 1992 page 122. Estimation thickness considering reflection control, H equal to 2.4 meter divided by 25 equal to 96 mm. So we try to use 100 mm for value of H. Next, durability, fire and bond requirement. Minimum cover concrete regard to bond, which is C minimum of B, 8 mm. The minimum concrete cover regard to durability C min equal to 10 mm. So for the durability minimum required, existing distance for R60 fire resistant, which is the value of A, is equal 6 meter, and then minimum concrete cover regard to fire is 10 mm. So value of C min A minus diameter of bar over 2 is 10 minus bracket 8 over 2. So allowance in design for deviation is 16 mm. So for the nominal cover, we can conclude that C minimum plus C deviation, which is V plus value of 10 and 6, and then we get 16. So commonly we use the C nominal cover is equal to 20 mm. Next, for the loading analysis, slab self-weight is 3.125 kN per meter square. For the permanent load excluding self-weight is 1 kN meter per meter square. And then the value of GK is 4.125. The value of QK is 3 kN per meter square. So design action, which is ND, the value of that one is 10.069 kN per meter square. So area bay that we use is 46.71 meters square. The value of bending moment, we use the formula WDL square over 8. The value is 7.20 kilonewton meter. And then the shear force, which is the value of V, we get that 12 kilonewton. So for the figure at the right side, we can see the value of bending moment and the diagram of bending moment, also diagram for shear force. And then next is for main reinforcement. Effective depth, what we can see here is 76 mm. For the maximum reinforcement area, we get 101.2 mm square over meter. And then if you use 0.0013 BD, and then we can get the value of maximum of AS is 400 mm per meter square. So as a summary of this, for the first interior support, value of K is 4.43 kN meter, value of K 0.167. For near middle at the span, the value of M is 3.87. For the value of AS, 123.22. For the interior support, value of M is 3.25. For the value of AS is 103.48. For the outer support is 2.06 for value of M, and value of AS is 65.59. Alright, for the shear, maximum design shear force, which is VED, is we use for the formula 0.6 F, and then we get the value is 12.89 kilonewton. Design shear resistance, which is the value of K, is 0.0022, which is less than value 0.02. So value for VRCDC 42,878.81 Newton. And then the value of V minimum or shear force minimum is 37.62. So VRD, we can conclude that 41.88 is greater than value for VED, which is 12.89. Alright, for the deflection, percentage of required tension reinforcement, the value of P is 0.013. Reference reinforcement ratio is 0.0050, and the factor for structural system is K equal to 1.35. Modification for span less than 7 meter is 1 meter. Modification for factor for less than 70 meter is 1.2, so it's less than 1.5 for steel area provided. Therefore, allowable span effective depth is ratio equal to 221.482. The last part is cracking. H equal to 100 mm, which is less than 200 meter. The main bar for maximum slab is 3H, which is less than 400 mm, which is the maximum one is 300 millimeter. And then the maximum bar spacing is 300 mm, less than S maximum. For the secondary bar, S maximum slab 3.5 H, less than 4.5 mm. For the maximum bar spacing is 300 mm maximum for S maximum slab. For the right figure 1, for the figure detailing, we can conclude that we use for the first main bar is we use H8-200, and then the secondary bar is H8-300 mm. That's all for one-way slab presentation of calculation and details. Thank you.